Hello, everyone. Thank you for the introduction, and thanks for coming to my talk today. My name is Alexander Totolic. I'm a security engineer at Fastly, where I work on ensuring that our hosts, our networks, and everything that is part of our infrastructure is built, operated, and running securely. A few different things go into making this successful. It includes threat modeling, host-based hardening, access control and audit, managing vulnerabilities, and monitoring for security events. But what I'm talking about you today is specifically just managing secrets, which is pretty a fundamental part of securing our systems. There we go. So the agenda for today, I'll first give you a brief introduction to Fastly and our infrastructure, and emphasizing those parts of our infrastructures that are really dependent on good secrets management. I'll also cover, just in brief, the various types of secrets that we deal with and historical approaches that we've taken to managing them. I'll get the hang of this eventually. I'll provide some background on Vault, and the reasons we're really excited to start using it. There are some really cool features that I want to make sure that everyone in the room is aware of before we get deep into the technical. And then I'll talk in some detail about Fastly's integration with Vault, and so both how we're deploying and operating it, but also the integrations for secrets management that we've worked on. So, Fastly, we are a next-generation real-time content delivery network. Our customers can use our API to configure and control their service configurations, to instantly purge content across the world, and to deploy advanced logging using Varnish configuration language. And since we are the edge of our customers' networks, it's really important for us to keep our infrastructure secure in the best ways possible. We're proud to count GitHub, Spotify, Twitter as some of our larger customers. We're really excited, big fans of open source, so we freely host content for Python packages, Ruby and Ruby gems, the Linux kernel, Debian, and HashiCorp's open source tools. They're all coming through the Fastly network. We're hiring. Talk to me about that if you want to know more. So Fastly's infrastructure is globally distributed, or else we wouldn't be a CDN. We use a mix of physical servers and virtual machines to make all the magic happen and spread across the world. We serve our customers' traffic through 28, I think, currently, points of presence. So those are all the red dots on the map, everywhere from Auckland to San Jose. The blue dots are planned locations where we're thinking of expanding our network. For each of these POPs, we follow a pretty standard design, one of a couple that we came up with over time. There are the bulk of this is occupied by caching servers. They're big, beefy machines with 2 terabytes of SSDs and almost a terabyte of RAM. These are the ones that serve customer traffic. We also have, very important in this infrastructure, our out-of-band management servers. And so these allow us to administer the network inside of these POPs. And they're also, these OOBs are also responsible for the way we initially bootstrap the whole POP. So when we do want to bring a new POP online, turning one of those blue dots to red, what we do after we find the site, sign the contract, etc., we'll have the hardware going to the data center. We'll have one of our data center technicians go on site, install rack, cable, everything. But at this point, they're also responsible for bootstrapping all of the servers in the POP, so they're actually useful to us. And it all begins by bootstrapping the out-of-band server. So bootstrapping the OOB server right now is done. It's just a network booting of a minimal operating system image that so there's a data center technician plugs in their laptop over just a point-to-point Ethernet, and it boots it over iPXE. And they just do this from a Vagrant box. So it's really important for us to keep it as lightweight as possible for the data center technicians, and they just do vagrant up, and with the network in place, everything will just work from that. But why I'm mentioning this is because I want to focus on this particular process, since it's really important for us to. This is where we have to deliver secret zero, like that initial piece of information that goes into the out-of-band server that gives it then access to all of the other secrets in our infrastructure. It gives it access to Chef, our configuration management platform, and then from that, everything that follows. So what do we talk about when we talk about secrets? It's pretty straightforward. I'm sure people in the audience are familiar. You got your usernames and passwords. It gives access to databases, systems protected by HTTP authentication. Maybe you need to mount an encrypted drive on a system that password needs to come from somewhere. There are API keys, whether it's your payment processor, whether it's OAuth tokens for connecting to S3 or other services. Maybe you use Slack for alerting, so you want to have an API key delivered that way. We host some of our software, our custom packages in our own repositories, and so we use mutual authentication between all the hosts that want to actually get access to these repositories. So repository keys are another secret. TLS keys, of course, you have to protect your connection with HTTPS, whether even if it's between your own infrastructure, if it goes over the internet. And sign and deploy keys as well. We have to run our code through configuration, through continuous integration. And so getting access to GitHub, getting access to everything that the code needs to end up running, and signing that code. So that's another kind of secret. We also have other types of data that we just consider sensitive. So customer, they're not strictly secret in the sense of credentials, in the sense of usernames and passwords, but customer information may include personally identifiable information. You don't want that as best as possible just living in a database somewhere. There are some configuration snippets, so our security tooling. We avoid putting too much information in source code because just in plain text, because that little bit of obfuscation and obscurity certainly just helps with our security goal. It doesn't replace it, but it certainly helps. And in just code, it can, there are parts of code, and not just what I referred to earlier in terms of using private code repositories where we store our packages, but just code that needs to be closely safeguarded. So probably the best way to make sure that your secrets don't leak is to never try to share them with anybody. But since in practice we do want to try to actually use them, we can start by hardcoding them in the disk image or in the AMI. You can put them in your source code. That works. Just stick them in configuration management, just in a data bag in Chef or in a Puppet attribute. Just put them in AWS, just in a cloud console, and they'll just get passed into your application. Yeah, of course, I'm not serious. I think we're all guilty at different points of doing some or all of these. I'm no saint. But none of these are actually secure in any sensible interpretation of that. And there are numerous horror stories of developers accidentally, putting their AWS credentials in GitHub or what have you. And bots scrape GitHub, and they'll automatically spin an EC2 instance in like 5 minutes and start Bitcoin mining. Amazon actually also does this, but they'll send you an email saying, hey, your key is in GitHub now. And even if you just use private repositories, if you put a credential in your source code, it's guaranteed that it will eventually leak. So improvements, maybe you'll build some kind of encryption system in-house, and I don't mean implementing your own cryptography, which is something we hopefully all know we really should stay away from, but just building tooling on top of existing crypto. The problem with that usually is that it's not your core engineering effort unless you're someone like HashiCorp building these sorts of tools for general use. It's usually an afterthought, and we've done this at Fastly too, where it's an afterthought, like we need encrypted credentials, there's nothing good out there, so we're going to just build something in-house. It's terrible. Then configuration management solutions have started more and more to provide options for this. So Ansible has Ansible Vault, Chef has Chef Vault. I see a pattern here with naming. There are also these are kind of steps in the right direction, but they do very much make some assumptions about your workflows. And ultimately, I think the biggest detractor from using just whatever your configuration management system comes built in with is that they really are only usable by systems that you control with configuration management. So it's really hard to have other things that don't read their config, or if you want to do some more advanced integration, they don't necessarily support those kinds of workflows. And then there's TPMs and so trusted platform modules and hardware security modules, purpose-built chips for storing your keys inside of hardware and not making it impossible to extract those keys for the most part. That's not always true. But the tooling, if you've ever tried to write code to work with these, it's abysmal. And you still end up having to build something on top of them. So we're here to talk about Vault. And if I were to come up with a list of all the things that I wished from a secrets management solution, Vault, even from version, I think, 0.3, had covered most of them. So I'm just going to cover a little bit of the ones that I think are more important. It's all over HTTPS, and so it's vendor and system agnostic. In that regard, you can easily integrate it with anything that can speak HTTP. It decouples storage from the actual encryption mechanism, so you can store the encrypted data in console, in Zookeeper, in backends that are meant for storage, rather than forcing all of this into another tool that's built for a different purpose, right? So it's very much the Unix philosophy of one tool for one job. The community is pretty good at adding support for additional backends, but it really allows Vault to focus on what it does best. Policies and access control, Nikki mentioned this as well, but they're really good for, particularly for your security engineers. But it allows very fine-grained control over who can read systems and what they can do with them. Operational control, encryption best practices. Since Vault uses, so Vault doesn't trust its storage backend, which means it needs to use an encryption mechanism that lets it detect if the storage backend has tried to tamper with the data, or if there were some accidental modifications that happened there, some data corruption. But Vault uses AES GCM, so all of that is taken care of for you, and as you know, has been audited. And for operational controls, the whole initialization and unseal process, where to be able to start Vault and to have it actually encrypt and decrypt secrets, you need at least a number, like a quorum of operators to agree to start the service. So that doesn't put too much information to the hands of just one person. And audit logging, for similar reasons, you can push basically every single operation that happens that Vault is involved with gets an audit entry, so that describes who did it, what did they do, and whether that was a legitimate operation or whether somebody's trying to use an expired token to interact with Vault. From the client's perspective, authentication is pretty easy. You'll pass in, and the client being either a user or a machine, you'll pass in a username and a password or a GitHub. There are a number of different ways to perform authentication. Vault gives back a token, and then everything else after that, every other operation is performed using this token. There are different authentication backends, so you have username and password. You can use TLS certificates for mutual authentication. You can even have it backed by LDAP if you already have an identity directory, or even GitHub. And secret backends, been previously mentioned again, but the generic backend lets you just store, it's a key value sort of approach to like storing data inside of Vault, but with backends that can generate credentials like the Postgres backend, you can actually say, I will get a username and password that's only valid for an hour, and those, when the lease is expired, those just get deleted, and it's great for, if you need to give somebody temporary access to your infrastructure, but ideally, if you mediate all of your access to databases or to SSH is another one that supports this, it's really great because you no longer have static credentials, which tend to be usually used and abused if they ever get leaked. And the cubbyhole backend is one that I think is really neat. Basically, for a cubbyhole backend, that Vault token, basically every Vault token has its own cubbyhole backend. All secrets that go into that namespace only exist, so they're only readable by that token, and they only exist for as long as the token exists. So if it gets revoked, if it expires, if it gets, they will just go away, and Vault will handle deleting them automatically. All right. So now that we have a bit of context around secret management and Vault in particular and some of its features, let's take a look at how Fastly's gone about deploying Vault. So we're using Console for the storage backend. There's great affinity here because they're both HashiCorp tools. Vault has a good story, a really great story around high availability, so it's really important. You still need the storage backend to be available for Vault to be useful. So having that always run and being dependable was really important. We are using 5 bare metal servers for this deployment. Physical machines were a hard requirement from when we started considering this project. We just didn't want to handle the risks associated with running this kind of infrastructure inside of a virtual machine in someone else's environment. There are just too many things that can go wrong, not necessarily intentional, but you have to worry about side channel attacks where people that are running another VM on your same physical host are trying to scrape your memory. There's research published on this. You have to worry about an accidental. You don't actually see if your VM ever gets copied accidentally or not by your cloud provider, and your Vault's decryption key is in memory, so it could be easily scraped after the fact. With the physical environment, it's not perfect, but you are certainly cutting out a lot of that risk. And for us, that was just not a debatable aspect. We're also isolating these servers from the rest of our infrastructure. And in fact, most of the security critical tools, whether that's Vault, whether that's a lot of our security logging and monitoring, they live in separate environments from production or corporate. The reason for that is partly just to get better access controls, because there are a lot fewer people that need to be able to log in or interact with these environments. Okay, that's now catching up with me. Sorry about that. But we're also splitting this because if something happens in production, so if there's a compromise, if there's a reliability issue, there are a couple of things that can happen. This split, this isolation allows us to go back to our security infrastructure. Chances are that whoever breached the production may or may not have breached the security bubble as well. But we can go there. We have some assurances around the integrity of the data in that environment. And so I strongly suggest, wherever possible, to use a separate Chef organization, a separate AWS organization, and different accounts for your physical hosting providers, et cetera, just a completely separate, just an entirely separate environment that way. And because Vault operates over HTTP, this is really easy now to integrate with everything else, where by contrast, when you're coupling configuration management with secrets management, you can't really easily do this. In some scenarios, it's impossible to, because your configuration management that goes into production is tightly coupled with that environment, and so you can't do this separation quite as easily. We just give one URL that our production infrastructure machines need to be able to talk to get the vault. We delegate a DNS zone to console, so we let console handle console using its service discovery to be able to point us to a live and healthy vault node, and that just kind of happens magically. We also restrict who we respond to on these DNS queries. So we were trying to limit it just to hosts in our infrastructure or things that we've provisioned through our cloud providers, as the case may be. Now for testing, before deploying all of this, I wanted to make sure that it all was going to work just fine. So what better way to do that than with a Vagrant cluster? The more interesting aspect of this is now I have an environment that I can hand over to other engineers that may want to work on integration with Vault, or they may just want to have a local system to be able to test against instead of testing directly against a production Vault server. And it's just another layer of code as documentation, so you can just refer back to what you did. Now, obviously, I can't go into every single detail of what we're doing, but I do want to talk a little more about the initialization and unseal processes for Vault. So when you start Vault, again, it comes online. The service comes online, but it does not yet have the encryption and decryption key that it needs to be able to decrypt everything that's in the storage backend. And the way to get that key is by having a quorum of operators greater than one that have to get together and basically just enter their individual unseal keys to reconstruct the Vault decryption key. And this uses Shamir secret sharing if you're into that sort of thing. Vault has built-in support for OpenPGP keys, and so when you actually initialize the Vault, there's never one person that sees all these shares. You just give it a list of PGP keys, and it generates the decryption, the unseal keys, and just sticks them directly into the, just encrypts them to the recipients, and then you can ship that ciphertext securely, because you really, really never want to have one person have eyes on all of the shares at any one time. And this process can be repeated every so often if you want to re-encrypt. If you want to change the master encryption key and just re-encrypt the whole thing all over again, you can do that easily. But one thing I want to caution against, because I've seen this come up a couple of times in mailing lists on IRC, et cetera, is bypassing this entire process by trying to automate the unseal process. So just bypassing the whole thing, because at that point you've put the trust for your system now is tied to the trust of this one script or whatever solution you come up with to perform the automatic unseal. And chances are that it's going to really weaken your overall security posture, and it really kind of puts into question why you're trying to use Vault. I'm sure there are situations where people wish they had automatic unseal, but I really think that that's something that's better handled through sort of operational practices and having a good runbook around events that might require that might lead you to think that you need that kind of feature. So going back to Bootstraps and thinking about when we're trying to turn those blue dots into red dots and we're trying to add new servers into our infrastructure and make them part of our fleet, And how can we make sure that this process is done securely with regards to that initial piece of information, that secret zero that I mentioned at the beginning. So there are two stages for us in this process. The first part is the enrollment of new hardware into our basically the metadata, enrolling this into our existing fleet. And then there's the actual on-site process that I mentioned a little bit at the beginning, when the data center technicians goes and turns the metadata into the actual physical, like running servers, useful servers in our infrastructure. So when we first receive hardware details, it's a much longer list than what I have on screen, but we receive the details from our hardware vendors. We put them into Chef. They have serial numbers and MAC addresses and whatnot. At the same time, there's a TLS client key and certificate generated for this new server. This will be secret zero once it actually lives on the server itself. But the client key and the certificate, now they're bound to policies related to the actual role of this server. So for an out-of-band, it only needs access to a certain set of secrets. And here you can actually enforce that these are the only secrets that it gets access to. In configuration management, you would say, these are the run lists, depending on what you're using. This is what the server should do. But unless your environment is a lot cleaner than most that I've seen, usually the reality is a little different. But with Vault, there's no way around it. With Vault, it will enforce and make sure that that client can only ever get access to the keys to the secrets that has been allowed through by the ACL. And the last part of the enrollment process is creating a new token in Vault with a limited use count of 2. We'll call this the enrollment token. So then we'll store the client key and the certificate in the cubbyhole of that enrollment token. And so now we're down to just one use left for this. So we've used the enrollment token to write another secret into that space, so that takes the count down by 1. And then we stored the enrollment secret itself in the generic backend at a path that only the data center technicians can read. They can read from. So when they go on site, they're connecting the laptop and they're ready to go. They issue their usual vagrant up. The only extra piece of information they need to provide is their regular authentication to Vault, their regular username and password. And the Bootstrap system, the bootstrapping tool, will take those credentials, will authenticate them to Vault, will use their Vault access to read back the enrollment token and send it back to the bootstrapping tool that's running on their laptop. It will then inject this into the out-of-band server that's now just booting over iPXC. And so, it's using just templating from iPXC itself. And once the out-of-band server has that enrollment token, it can use the last use count, go back to Vault, and get the client key and the certificate. And these are now its actual authentication mechanism going forward. So they are persisted to disk. They are unique to that out-of-band server, but they will be... so basically that's secret zero at that point. Now, there are a few things, there are a few windows where the cubbyhole token could be extracted and misused. The advantage is that because we have, because of auditing and because of logging separately, we'll get alerted. So if the server doesn't come online, somebody's going to figure out, okay, what's the problem? Why are we short 20 servers in our infrastructure? And we'll review the logs and we'll see, well, this token is used here, but the server never came online. So it's either an operational problem or it's a security problem, but either way, there's something broken at some part of the process that we need to go back and fix and address. And I know it sounds like there are quite a few tokens in flight here, but they're all taken care of by tools, and so there isn't really a lot that operators see unless they really go out of their way to try to extract things. And then we can now extend the system to, we can extend this mechanism to other systems with the difference that where the data center technician can read a token to bootstrap the out-of-band server, data center technician will never need a token to bootstrap a cache. So the roles that are assigned to different clients and the different operators and to different machines can help us with making sure, you know, this person is responsible for this task, and then the out-of-band server's own ACLs, their own policies, allow it to work, to be used to automatically bootstrap the cache. So in terms of some of some of our future plans, there certainly I would like to see more of our applications use Vault natively. Ideally, one day there will be no secrets, nothing on disk, so that anytime you do have to suffer a security breach, even if they scrape memory, they'll only find secrets that are short-lived, relatively, and that are unique to that machine. So this is sort of above and beyond what I have seen in my experience, what a lot of environments consider in their threat model. But I really think that that's kind of one of those things that nothing before Vault really easily enabled you to do. I would also like us to use more ephemeral secrets. I also think that that's it's kind of tied into my earlier point, but with the ability to have these sorts of accesses expire, you can now control very carefully, say, if people are only allowed to log into production when they're on call, then you can tie that in, and so you will generate SSH. You will only allow SSH access for people that are on call rotation, and their access will just automatically go away whenever their shift ends. Same with contractors that you might need to provide access to databases and things like that. So I'd really like us to also use these more, but I run into, obviously, it requires a lot of careful testing just to make sure it don't bring down the infrastructure because SSH is no longer working. And of course, Mitchell mentioned today earlier the wrapping mechanism, which seems a little similar to what I described here, but that one's really focused for virtual machines, and you noticed that I ignored that topic almost entirely because we had considered extending this mechanism through a cloud deployment, through our cloud deployment tool to do the same thing, but a lot slower than you would get than if you were doing it with auto-scaling. So for something like auto-scaling, it sounds like you need resource wrapping. So I'd really going to go home and look at that a little more. But in brief, I just gave you a quick look at Fastly, kind of what we're doing with Vault, how we're operating our security infrastructure around secrets management. If you have any questions, I'd love to hear more during the rest of HashiConf. I am also really interested to hear from people that either think that Vault might not work for them, or but obviously I'm always curious for more details around kind of what you're using, what kind of cool things you're doing with it. So I hope to chat with many of you during the next couple of days. And if you, for whatever reason, want to get in touch, it's my email. There's a Keybase handle in case you're into GPG. And I have been idling on the Freenode channel for Vault since last year, but I'm not very chatty. I'm a little Well, that's it from me. Thank you. And I don't know if we have time for questions, but 2 minutes? OK. So I think there's a microphone going around if anybody has any questions right now, unless you're really in a rush for lunch. All right. Thank you.